Hello everyone, today we're going to start chapter 4, polynomial functions, and first we're going to talk about what a polynomial is. A polynomial is a function of this form, and we're going to have coefficients, we're going to have variables, we're going to have exponents. Each one of these has a specific property. These coefficients have to be real numbers. So this coefficient for this x term is a real number. The coefficient for this x term is a real number, and so on. Also notice that each variable here has an exponent. These exponents, they have to be integers, positive integers. If you don't remember what an integer is, here's a review. The integer set of numbers includes 0. All the positive numbers to infinity and all the negative numbers to infinity. This means that there are no decimals or fractions in this set of numbers. For exponents in a polynomial function, I'm only going to be able to use the positive integers and 0. So you'll never see a polynomial function written with an exponent that's not a positive integer. If you do, then that is not a polynomial function. For example, I'm going to give you an example of a polynomial. Let's say I write f of x is equal to 4x cubed minus 3x squared plus 2x minus 4. This is a polynomial function. Notice all my coefficients are real numbers. All my exponents are positive integers. On the contrary, if I write f of x is equal to 4 x cubed minus 6 over x, this is not a polynomial function because this x has a negative exponent. We'll see why in the next slide. Also, the degree of a polynomial, when we talk about the degree of a polynomial, what we mean is what is the highest powered exponent. So for example, in this function here, the highest power is a 3. So we call this polynomial a degree 3 polynomial because 3 is the highest exponent or the largest exponent in the whole expression. Here, I can't talk about a degree for the polynomial because this is not a polynomial. Let's see our next slide to see some examples. If I ask you if this function is a polynomial, I want you to tell me if it is a polynomial and tell me the degree of the polynomial if it is a polynomial. So for this example, let's check. Are the coefficients real numbers? Yes. Are the exponents positive integers? Yes, they are. So this is a polynomial, and this is going to be a degree 4 polynomial because 4 is the largest exponent in this expression. Okay, our next example, is this a polynomial? Now I'm saying that this function is equal to 8. This is a function, it's a constant function. It is a polynomial. Some people will say it's not a polynomial because they don't see a variable in this expression, but remember that 8, I can rewrite this as 8x to the 0 power. Remember, x to the 0 power is the same thing as 1. Anything you raise to the 0 power becomes 1. So this becomes 8 times 1, which is equal to 8. So it is a polynomial function. It is written in the form of a polynomial. So I can say that it is a polynomial function, and the degree for this function is 0. This is a degree 0 polynomial function. Our next example, is this a polynomial function? Well, let's check. The coefficients are real numbers. I have a variable here, and the exponent for this variable, be careful, this is not exponent 1. If this is the square root of x, remember I can rewrite the square root of x as x to the 1/2 power. So this means that the exponent for this expression is a fraction, not a positive integer. So this expression here is not a polynomial function because the exponent is a fraction. My next example here, I gave you a preview of this in the previous slide. I can rewrite this whole expression as -9, and I can bring this x up to the numerator by writing it like this, plus 3x to the 4th power. Now, is this a polynomial function? Well, according to our rule, we can only have positive integers, and here I have a negative integer. So this disqualifies this function as a polynomial function. Okay, so when you're asked if an expression is a polynomial function or not, be careful. Make sure that all of your exponents are positive integers. Okay? On this next slide, I'm also going to talk about the leading coefficient. The leading coefficient is the coefficient that corresponds to the highest power of the variable. So I'm going to give you an example here. Here's an example. I give you this polynomial, and I'm going to ask you what the degree of this polynomial is, what the leading coefficient is, and the constant term. So you already know how to figure out the degree. The degree is the largest exponent in the whole expression. That would be 7. So this would be a degree 7 polynomial. Also, the leading coefficient is the coefficient that belongs to that term with the highest exponent. So the leading coefficient in this case is 6. And the constant term is this term here that has no variable next to it. So my constant term would be a 10. For our next example, I have x cubed. So the degree for this polynomial is degree 3. That's the only exponent in the whole expression, so it's the largest one. The leading coefficient here, when there's nothing written in front of my variable, that means that the coefficient is a 1. And the constant term is 0 because there are no constant terms here. Next example, I have 12. This is a constant, but remember that I can write any constant like this. So when I ask you for the degree of this expression, the degree would be 0 because that's the exponent for this variable. It's the only exponent, so it's the largest one. And the leading coefficient for the largest exponent term is 12. And also, since this equals 12 times 1, which is 12, 12 is also my constant term. For this expression, you have to be very careful. Whenever you look at a polynomial, make sure that it is written in descending order of exponents. That means that I'm going to order all of my exponents from largest to smallest. So I'm going to rewrite this expression. My largest exponent is 9, so I'm going to make that my first expression. The next largest exponent is x to the 8th power. Now be careful when you rewrite these, make sure you take the expression with the symbol that's in front of it, okay? So plus x to the 8th power. And now my next one would be this expression with the 7, so make sure you grab the whole, the symbol in front plus the term. So this would be plus 3x to the 7th power. Next one would be this one, so grab the whole thing plus 2x to the 6th power. And then I have this expression here. That's the next term, minus 2x, and the last one is minus 4. Now, when I write my polynomial in descending order of exponents, we call this this is written in standard form. That's what we say when it's written in that form, standard form of the polynomial. Now that I have it in standard form, I can better see what the degree of this polynomial is. So when I ask you for the degree here, be careful with this term. This term is 0 times this. So this becomes 0. So this term really does not exist in my polynomial. Sorry about that. This doesn't exist in my polynomial. So my polynomial really starts with my 8 term here. So this would be a degree 8 polynomial. My leading coefficient, well, the coefficient for this term is a 1. And my constant term is -4. -4. So now I'll have you practice some. Here are 4 examples for you to do to tell me the degree, the leading coefficient, and the constant term. And be careful, make sure that before you start stating these, make sure that these expressions are indeed polynomials. I hope you understood this topic. My next presentation will be on long division. So I'll see you there. Bye.